Welcome to lecture 11 of module 3 in database management system. In the last session we have started with the index structure. In that we have covered the primary index technique, and also we have discussed a few numerical problems based on the primary indexing. And today we are going to cover the clustering index and the secondary index, okay, and also some problems based on these concepts. So first we are going to cover the clustering index. So what do you mean by a clustering index? The most important speciality of a clustering index is that the file record or the main data file is actually ordered on a non-key field. In the primary indexing we have seen that the record file or the data file was ordered according to the primary key, but here it is a non-key. It is ordered ordered in a non-key field. Okay, so such field is called a clustering field. So I will just show you the example of a clustering index. So this is a clustering index. You can see that this field, okay, this is a main data file that is stored in the disk, and this particular record is stored in a block, first block. This is in the second block. This is third block, fourth, fifth, and sixth. Okay, so here you can see that uh, the 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 details are actually ordered, but they are non-key. Why it is non-key? Because this how can we say that it is non-key? We can say that it is non-key because here the values are repeating. See how 1 is repeating 3 times, 2 is repeating 2 times, 3 is repeating 4 times, 4 is repeating 2 times, 5 is repeating 4 times, and so on. So this cannot be considered as a key or a primary key. So that is why it is saying that in a clustering index, the file records are actually physically ordered on a non-key field. This is a non-key field. Clear? So such a field in the data file is called a clustering field. So this field is called a clustering field. Okay, clear? Now we will talk about the index field. So index field, as the same architecture we have seen in the primary index, it is having two fields. Okay, index field is having two fields. The first field will be the clustering field. The first field is called the clustering field value, and the second field is called the block pointer, which will be pointing to the corresponding blocks. Okay, so what is the speciality of this clustering field value? Look here, in the clustering field we saw that we are having repeating values, but in the clustering field value in the index file it is not having any repeated values. Okay, so this means that there will be only one entry in the clustering index for each distinct values of the clustering field. Okay, since here it is having 3 ones, but in the clustering field value it is having only single one. Okay, so even though the clustering field is having multiple values, for that multiple values only one entry will be there in the index. Okay, that is why it is saying that there is only one entry in the clustering index for each of the distinct values. Okay, so these are the point that is being written here. Clear? So file records are physically ordered on a non-key field. Okay, file records are physically ordered, but in a non-key. These are non-key. Clear? But it is physically ordered. Such fields are called a clustering field. So this field is called a clustering field. It is an ordered file with two fields. That is, a clustering index is also an ordered file. Okay, clustering index is an ordered file with it is having two fields. Okay, so clustering index is also an ordered file, but it is having what, two fields. What are the fields? The first one is the clustering field of the data file. Okay, clustering field of the data file, and the second one is what, block pointer. Okay, second one is the block pointer. Okay, and the next point is that there is only one entry in the clustering index for each of the distinct values. Okay, that is what I have explained just now. Okay, even though we are having repeated values in the clustering field, but only a single entry for this clustering field will be there in the clustering field value in the index file. Okay, it is a next point is it is a non-dense index or sparse index. So this is a sparse index or non-dense index. Why it is called a sparse index or a non-dense index? Because for each index entry it has only a few index entry for the clustering field values. See here we are having multiple 3 ones, two twos, and 4 threes and so on. Okay, but for all those multiple values we are having only a single entry for that. Okay, അപ്പം നമ്മൾ ഇതിനകത്തുള്ള മൾട്ടിപ്പിൾ വാല്യൂസ് ഉണ്ടെങ്കിൽ പോലും അതിൻ്റെ ഒരു സിംഗിൾ എൻട്രി മാത്രമേ ഇതിനകത്ത് വരുന്നുള്ളൂ. ദാറ്റ് ഈസ് കോൾഡ് സ്പാർസ് ഇൻഡെക്സ്. ഓക്കെ, സ്പാർസ് ഇൻഡെക്സിൻ്റെ ഡെഫിനിഷൻ നമ്മൾ ഓൾറെഡി കണ്ടതാണ്. സോ സ്പാർസ് ഇൻഡെക്സ് ഈസ് നത്തിങ് ബട്ട് ഇറ്റ് ഹാസ് ഇൻഡെക്സ് എൻട്രി ഓൺലി ഫോർ സം ഓഫ് ദ കീ വാല്യൂസ് ഓർ സം ഓഫ് ദ സെർച്ച് വാല്യൂസ്. ക്ലിയർ? So that is why it is called, this is a non-dense index or sparse index. An index created on the clustering field is called a clustering index to speed up the retrieval of the record that have the same value of the clustering field. So this means that the index value we have created for clustering field is called the clustering index. Okay, why are we using this clustering index? In order to speed up the retrieval process. Okay, that is what has been mentioned here. A clustering index is another example for a non-dense index. Already we have said that concept, because it has an entry for every distinct values of the indexing field. Okay, so it can, this index entry is having only a distinct value of the distinct value of the indexing field. Okay, so that is why it is called a non-dense index. Clear? അപ്പോൾ ഇവിടെയുള്ള എല്ലാ വാല്യൂസിനുള്ള എൻട്രി ഇതിനകത്തില്ല, അതുകൊണ്ടാണ് ഇതിന് നോൺ ഡെൻസ് ഇൻഡെക്സ് എന്ന് പറയുന്നത്. ഓക്കെ, there is an issue with the clustering index. That is, if you try to insert new record, the placement of the new record will be a challenge in this scenario. For example, look at here. Suppose I want to insert a new record of the department number 2. Okay, so how can we insert? There is no space for inserting the value 2, because it is already filled. There is no gap between these two. Okay, so what can we do? So this is a problem for the clustering index. Anyway, we can't store the record for the 2 here at last, because this has to be ordered. Since we told the configuration that this is an ordered list. So in order to add a new record for the department number 2, it will be a tedious task. Okay, so for that we are having a solution for it. So what is the solution? So they are suggesting that we have to reserve the entire block for each value of the clustering field. That, for example, for department number 1, we will block an entire block for the department number 1. For department number 2, we will block the entire block. Okay, for department number 3 also we will block the entire block. Okay, then it will not be a problem. How? That is the next figure they are mentioning. This is the next figure. Okay, see here, say they have reserved a whole block for the whole block for the department number 1. Look here. Clear? Then whole block for the department number 2. Clear? And whole block for the department number 3. Clear? Then suppose here assume that this only four records can be stored in a single block. Assume that. Okay, then we want a new record for department number 3. So how is it possible? We will take a new block. We will take a new block and we will create a pointer that points to this new block. Okay, for that we will create a block pointer here. കണ്ടോ ഇവിടെ ബ്ലോക്ക് പോയിൻ്റർ ഉണ്ടോ? അപ്പോൾ ആ പ്രീവിയസ് ഫിഗറായിട്ടുള്ള വ്യത്യാസം നോക്കിയാൽ ഇവിടെ ബ്ലോക്ക് പോയിൻ്റർ ഇല്ല. ഓക്കെ, ഇവിടെ എന്താണ് ബ്ലോക്ക് പോയിൻ്റർ ഉണ്ട്. എന്തിനാണ് ബ്ലോക്ക് പോയിൻ്റർ? ദിസ് ബ്ലോക്ക് പോയിൻ്റർ ഈസ് ആക്ച്വലി യൂസ് ടു പോയിൻറ്റ് ടു ദ next block that has the same department number or the same value. ഓക്കെ, അപ്പോൾ എന്തുകൊണ്ടാണ് ഇവിടെ ഇത് കൊടുത്തത്? ഇവിടെ നമുക്ക് 3 സ്റ്റോറി ആൻഡ് ഈ ബ്ലോക്കിൽ സ്പേസ് ഇല്ല. വി ആർ നോട്ട് ഹാവിങ് എനി സ്പേസ് ടു സ്റ്റോർ the record, a new record with the department number 3. Okay, so what we have done, we have created another block, a new block, and we have made a block pointer that is pointing to this new block. Okay, clear? So that is why in these blocks we have actually created a null pointer, because this block pointer is not pointing to any other new block. Okay, that is why they have given a null pointer here. Here also it is given a null pointer. Clear? Here also it is like that. Here also. But look at here. Here we have 6. We have to store the details of 6. For that they have already taken the 4 records. Okay. So in order to add a new record, what they have done, they have created a new block, and they have inserted the 6 value there and created the block pointer to that particular block. Clear? So that is the advantage of the block pointer in the data file. Clear? Here also it is a block pointer. What is the purpose of this block pointer? This block pointer is actually pointing to each and every block. Clear? So this is the concept of, this is the purpose of creating. This is a new configuration. Why they have creating this? Because in order to, since the list is sorted, in order to insert or delete a new record will be a tedious task. Okay, so in order to do that, they have included a block pointer here, and this block pointer can be pointing to a new block that is to be created. Okay, so this is the concept. So the same theoretical explanation is given here. Here record insertion and deletion still cause a problem, because the data records are physically ordered. Since the data records are physically ordered, it will be very difficult to perform insertion and deletion. To avoid the problem of insertion, it is common to reserve a whole block of each value of the clustering field. Okay? So we will reserve the entire block for the entire clustering field value. Okay, for department number 1 we will block the entire block. We will reserve the entire block. Okay, for department number 2 we will reserve the entire block. If that block is not sufficient, we will take a new block and assign a block pointer to this new block. Okay, all records with that value are placed in the block. This makes insertion and deletion relatively straightforward. Okay, so by making this modification, it will be more easier. Okay, so this is the concept of clustering index. So this is the basic clustering index figure, and this is the advanced one. Okay, modified one. Clear? One more thing I have left it out, that the block pointer, look at here, the block pointer here, the clustering field value 1, for clustering field value 1, the block pointer is pointing to the first block. Okay, for block pointer for the clustering field value 2, the block pointer is again pointing to here. Why it is here? Because the 2 is available. The 2 is available at the first occurrence of 2 is happening in which block? The first occurrence of the 2 is occurring in which block? See, this block. Okay, so that is why the reference for the clustering field 2 is actually pointed here. Okay, similarly 3. Okay, 3, the clustering field value 3. So what is the in which block the occurrence of 3 is occurring first? See here, in this block. Okay, in this block the occurrence of 3 is occurring, so it is pointing to this block. Clear? Similarly 4, when in which block the occurrence of 4 is in which block the 4 is occurring in the first time? Here in this block. Okay, similarly other. Okay, similarly they have created all these. This is how the block pointer is pointing to the corresponding blocks. Clear? So hope all are clear with the clustering index with these two configurations. So why they are going for this configuration? In order to perform insertion and deletion without any problem. Okay. Next concept is secondary index. So we don't have any problems related to numerical problems in the clustering index. Now we can move on to the secondary index. So what is the concept of secondary index? The main configuration of the secondary index is that the data file or the main file is unsorted. In the above two scenarios, that is in primary indexing as well as in clustering index, the data file was sorted, but here it is entirely unsorted. Okay, it is unsorted. Next configuration, it says that secondary index may be created on the field that has so it has two fields. The secondary index is having two fields. The first one is a candidate key. Candidate key is nothing but a key, a unique key. Okay, that is to identify a particular record, that is called candidate key, or a non-key field with the duplicate values. Okay, so secondary index can be created either using a key or a non-key field. That is a summary. ഓക്കെ, അപ്പോൾ ഒരു സെക്കൻഡറി ഇൻഡെക്സ് എങ്ങനെയൊക്കെ ക്രിയേറ്റ് ചെയ്യാൻ പറ്റും? ഒന്നുകിൽ ഈ ഒരു കീ ഉപയോഗിച്ചിട്ട് ചെയ്യാൻ പറ്റും, ഒരു യുണീക്ക് വാല്യൂ റെക്കോർഡിന് യുണീക്കായിട്ടുള്ള ഒരു റെക്കോർഡിനെ റെഫർ ചെയ്യുന്ന കീ വെച്ച് ചെയ്യാം, അല്ലെങ്കിൽ ഒരു നോൺ കീ വെച്ച് ചെയ്യാൻ പറ്റും. ഓക്കെ, അപ്പോൾ അതെങ്ങനെയാണെന്നുള്ളതാണ് ഇതിൽ പറയുന്നത്. ക്ലിയർ? സോ let us see the index file. So this is the secondary index file. Okay, as the configuration says that the data file, this is the data file. The data file here, it is unsorted. Look at here, it is unsorted. Clear? Even though it is unsorted, actually the index field is actually unique. That is, it is not repeating. റിപ്പീറ്റ് ചെയ്യുന്നുണ്ടോ ഏതെങ്കിലും നമ്പേഴ്സ്? ഇല്ല. ഓക്കെ, അപ്പോൾ ഇത് യുണീക്കാണ്, പക്ഷേ ഓൺലി തിങ് ഇറ്റ് ഈസ് നോട്ട്, ദിസ് ഫീൽഡ് ഈസ് നോട്ട് അൺസോർട്ടഡ്. ക്ലിയർ? ബട്ട് ഇൻ ദ കേസ് ഓഫ് index file, all these values will be considered as the index value, and this is the index value will be index field value will be sorted. Okay, look at here, it is having values from 1 to 24. Okay, this is also having values from 1 to 24, but it is not sorted. Clear? So that is another specialty. So here the data file is unsorted. Okay, but in the case of index file it is sorted. Okay, clear? So all the values in the data file, all the values, all the key field values in the data file is actually present in the index file. Okay, അപ്പോൾ ഇത് ഇവിടെയുള്ള എല്ലാ വാല്യൂവിൻ്റെയും റെഫറൻസ് ഏതിലുണ്ട്? ഇൻഡെക്സ് വാല്യൂ, ഇൻഡെക്സ് ഫീൽഡ് വാല്യൂയിലുണ്ട്. ഓക്കെ, സോ ദിസ് ടൈപ്പ് ഓഫ് ഇൻഡെക്സ് ഫീൽഡ് ഈസ് കോൾഡ് വാട്ട്? ഡെൻസ് ഇൻഡെക്സ്. ഓക്കെ, സോ ദിസ് ഈസ് ഓൾസോ കോൾഡ് ഡെൻസ് ഇൻഡെക്സ്. ക്ലിയർ? അപ്പോൾ ഈ സെക്കൻഡറി ഇൻഡെക്സ്, ദ സെക്കൻഡറി ഇൻഡെക്സ് ക്യാൻ ബി ക്രിയേറ്റഡ് യൂസിങ് എ കീ. ഓക്കെ, ഒരു കാൻഡിഡേറ്റ് കീ അല്ലെങ്കിൽ യുണീക്ക് കീ വെച്ചും കൊടുക്കാം, അല്ലെങ്കിൽ ഒരു നോൺ കീ വെച്ചും കൊടുക്കാൻ പറ്റും. ഓക്കെ, അതാണ് നമ്മൾ ഇവിടെ ഇതെന്ന് പറയുന്നത് കീ വെച്ചിട്ടുള്ളതാണ്. ഓക്കെ, സോ ദിസ് ഹിയർ ദ ഫീൽഡ് ഈസ് അൺസോർട്ടഡ്, ബട്ട് ദിസ് ഫീൽഡ് ഈസ് ആക്ച്വലി എ കീ, ഒരു യുണീക്ക് കീ ആയിരിക്കും. ക്ലിയർ? ഇനി നോൺ കീ വെച്ചിട്ടുള്ള കോൺഫിഗറേഷനും ഉണ്ട്, ദാറ്റ് യു വിൽ സീ ഇൻ ദ നെക്സ്റ്റ് slide. Okay, clear? So candidate key has a unique, the secondary index can be created using a unique key, a candidate key or a non-key. Clear? Index field, now they are talking about the index field. This index field it is having how many subdivisions? 2 fields. Index file it is having 2 fields. ഏതൊക്കെയാണ് ഫീൽഡ്സ്? The first field is a key or a non-key. So first field can be this value. First key value will be this value. Okay, this index field value can be a key or a non-key, and the second field is a block pointer. Okay, so second is a block pointer or a record pointer. Clear? It is an example for dense index. Okay, this is dense index example. Okay, because why? Because it is having the reference for all the search values in the data file. ഇതിനകത്തുള്ള എല്ലാത്തിൻ്റെ റെഫറൻസ് നമുക്കിവിടെ ഇൻഡെക്സ് ഫയലിനകത്തുണ്ട്. സോ ഇറ്റ് ഈസ് കോൾഡ് ഡെൻസ് ഇൻഡെക്സ്. ഓക്കെ, അപ്പോൾ ഇവിടെ പോയിൻ്റർ പോയിരിക്കുന്നുണ്ടോ? ഫോർ ഇൻഡെക്സ് വാല്യൂ 1, ദ പോയിൻ്റർ വിൽ ബി പോയിൻറ്റിങ് ടു ദാറ്റ് ഇൻഡെക്സ് വാല്യൂ 1. ഓക്കെ, അപ്പോൾ ആ രീതിയിലാണിത് ചെയ്തിരിക്കുന്നത്. A secondary index can also be created using a non-key field. So this secondary index is actually created based on a key field value. Okay, നമുക്ക് non-key ഫീൽഡിലും ചെയ്യാൻ പറ്റും. Okay, here there will be numerous records in the data file that have the same value in the indexing field. So that means that since we are actually since here they are saying that the secondary index can be created using a non-key field. So since we are creating a secondary index using a non-key field, that means that there will be a numerous records in the data file that having the same value. ഒരേ വാല്യൂ ഉള്ള ഒരുപാട് റെക്കോർഡ്സ് ഉണ്ടാവും. നമ്മൾ നേരത്തെ കണ്ട പോലെ ഒരുപാട് വാല്യൂസ് ഉള്ള സെയിം റെക്കോർഡ്സ് ഉണ്ടാവും. ഹൗ? ലുക്ക് ഹിയർ, 3. There are 3 ഉണ്ട്. Then any more 3? Yes. Second 3, then third 3, fourth 3. Okay, so 4 3s are available. Okay, so here the values are repeating since it is not a key field value. It is not a key value since the values will be repeating. Okay, so in that case, how can we modify this secondary index? Okay, that is the configuration that we are going to study now. So here the block pointer is not pointing directly to the data file. Instead, the block pointer is pointing to another disk block which contains the record pointer. Okay, ഇപ്പോൾ റെക്കോർഡ് പോയിൻറ്ററിലോട്ടാണ് ഈ ബ്ലോക്ക് പോയിൻറ്റർ പോയിൻ്റ് ചെയ്യുന്നത്. എന്താണ് ഈ റെക്കോർഡ് പോയിൻറ്റർ? The record pointer is actually the pointer to the each repeating records. For example, look at here, the field value 1. Okay, this block pointer is actually pointing to this record pointers. Okay, so the first record pointer, it is pointing to the first one. Okay, second record pointer, it is pointing to the second one. The third record pointer is pointing to third one. Clear? So since there are 3 ones with a record with 3 ones, there will be 3 record pointers. Clear? Next, field 2, field value 2. Here the block pointer will be pointing to a record pointer. Okay, this record pointer will be pointing to the record having the value 2. Clear? So this first record pointer will be pointing to this 2. The second record pointer will be pointing to where? Will be pointing to this. Okay, so there are only 2 2s are here. Okay, similarly for 3. So 3, the block pointer will be pointing to the record pointer. Okay, the first record pointer will be pointing to the first 3. The second record pointer will be pointing to the second 3. Okay, third record pointer will be pointing to the third 3. Okay, and so on. Clear? So how many repeated records are here for the same value, that much record pointers will be here. Clear? That is the difference here. Okay, so that is the difference of secondary index carried out on non-key values as well as using key values. ഓക്കെ, ഇതിൽ കീ വാല്യൂസ് ആണ്. അപ്പോൾ റിപ്പീറ്റഡ് വാല്യൂസ് ഇല്ല. ഇവിടെ നോൺ കീ ആയതുകൊണ്ട് റിപ്പീറ്റഡ് വാല്യൂസ് ഉണ്ട്. അപ്പോൾ റിപ്പീറ്റഡ് വാല്യൂസ് ഹാൻഡിൽ ചെയ്യുന്നത് എങ്ങനെയാണ്? യൂസിങ് record pointers, blocks of record pointers. So why it is called why it is mentioned blocks of record pointers? Because these record pointers are also disk blocks. Okay. അപ്പോൾ ഇതിൻ്റെ എക്സ്പ്ലനേഷനാണ് ഇവിടെ പറഞ്ഞിരിക്കുന്നത്. The block pointer in the index entry point to a disk block which contains a set of record pointers. Okay, so block pointer is pointing to a what? A record pointer. Disk blocks of record pointers. Okay, clear? Each record pointer in the disk points to one or more points to one of the data file. Okay, അപ്പോൾ ഓരോ റെക്കോർഡ് പോയിന്ററും is pointing to one of the data file. Okay, so this record pointer will be pointing to a particular data file record. Okay, so this is the configuration of what? Secondary index and a clustering index. Okay, so in each of these indexes they are having two configurations. Secondary index in രണ്ട് configuration ഉണ്ട്, ഇതിനും രണ്ട് configuration ഉണ്ട്. Okay, now a numerical problem based on secondary index. Okay, same formula, നമ്മൾ നേരത്തെ കണ്ട same formula is applied here also. So given an unordered file, okay, file comma number of records, okay, no എന്നല്ല number of records in the data file is 30,000 blocks. Okay, 30,000. Okay, number of records എന്ന് പറഞ്ഞാൽ 30,000. The block size is 1024 byte. The length of each record in the data file is 100 byte, and the length of each record in the index file is 15 byte. Okay, so find the blocking factor, number of blocks in the index file, number of block access required in the index file. So they have given what? They have given the unordered file. They have talked about unordered file. Okay, so unordered file means it can be index file. Unordered file means that this unordered file, if the data file is unordered, only we can only apply the secondary index. Okay, അതാണ് നമ്മളിപ്പോൾ പഠിച്ചത്. Okay, that means if the data file is unordered, okay, unordered, it can only be secondary index. Okay, അപ്പോൾ unordered ആണ്, and the number of records, okay, അപ്പോൾ unordered data file എത്ര records ഉണ്ട്? 30,000 records. So here, so look at here, so these are unordered, is having 30,000 records. Okay, 30,000 records ഉണ്ട്. Then the block size is 1024 byte. Okay, 1024 byte. Then the record size is 100 byte. ഒരു റെക്കോർഡിൻ്റെ സൈസ് എന്ന് പറഞ്ഞാൽ 100 byte. Okay, the length of the each record in the index file is 15 byte. അപ്പം ഇൻഡെക്സ് ഫയലിൻ്റെ ഒരു റെക്കോർഡ് സൈസ് എന്ന് പറയുന്നത് 15 byte. Okay, in index file the record size is 15 byte. Okay, since here the 1024 is the block size, this can be applied for the index file also. In index file also one block size will be 1024. Okay, so these all concepts we have studied in the previous session. Okay, so they have asked to find the blocking factor, number of blocks in the index file, and number of block access in the index file. Okay, they asked to compute the blocking factor, the number of block and the access required based on index file. അപ്പോൾ ഇൻഡെക്സ് ഫയലിൻ്റെ മാത്രം കണ്ടുപിടിച്ചാൽ മതി. Okay, in the last problem we have computed these factors for both the main file as well as the index file. But here they have they have asked about only about the index file. So we need to compute these factors only based on only for this index file. Okay. First, blocking factor. So what is the blocking factor? Blocking factor means number of records per block. ഒരു ബ്ലോക്കിനകത്ത് എത്ര റെക്കോർഡ്സ്, ഒരു ബ്ലോക്കിനകത്ത് എത്ര റെക്കോർഡ്സ് പറ്റും എന്നുള്ളതാണ് ബ്ലോക്കിംഗ് ഫാക്ടർ. ഫോർ ഈച്ച് റെക്കോർഡ് ഹൗ മെനി ബ്ലോക്സ് ക്യാൻ ബി പോസിബിൾ, ദാറ്റ് ഈസ് കോൾഡ് ബ്ലോക്കിംഗ് ഫാക്ടർ. So number of records per block. The formula is block size by record size. Okay, what is the block size? 1024. What is the record size? 15 byte. Okay, നമ്മൾ ഇൻഡെക്സിൻ്റെയാണ് കണ്ടുപിടിക്കുന്നത്. We are computing these factors on index. Okay, computing these factors for index. Okay, so block size is 1024 and file size is record size is 15 byte. Okay, so 1024 by 15. So it is a floor function. So floor function 1024 by 15, it will be approximated to 68 records. Okay, 68.2 ആണ് അതിന് value. Since it is a floor function, it is approximated to 68 record. Okay, അപ്പോൾ ഫ്ലോർ ഫംഗ്ഷൻ എന്താണെന്നുള്ളത് എല്ലാവർക്കും അറിയാം. ഫ്ലോർ ഫംഗ്ഷൻ ആൻഡ് സീലിംഗ് ഫംഗ്ഷൻ എല്ലാവർക്കും അറിയാം. ഓക്കെ, നെക്സ്റ്റ് നമ്പർ ഓഫ് ബ്ലോക്സ് ഇൻ ദ ഇൻഡെക്സ് ഫയൽ. നമ്പർ ഓഫ് ബ്ലോക്സ് ഇൻ ദ ഇൻഡെക്സ് ഫയൽ. ഓക്കെ, അത് കണ്ടുപിടിക്കണം. ഒരു ഇൻഡെക്സ് ഫയലിൽ എത്ര ബ്ലോക്സ് ഉണ്ട്, 1 2 എത്ര ബ്ലോക്സ് ഉണ്ടെന്നുള്ളത് അടുത്ത പഠിക്കുക. ഓക്കെ, സോ ഇറ്റ് ഈസ് ഈക്വൽ ടു നമ്പർ ഓഫ് റെക്കോർഡ്സ് ഇൻ ദ ഇൻഡെക്സ് ഫയൽ ഡിവൈഡഡ് ബൈ ബ്ലോക്കിംഗ് ഫാക്ടർ. ഓക്കെ, അപ്പോൾ ഇത് കണ്ടുപിടിക്കണം. എന്ത് വേണം? വി റിക്വയർ നമ്പർ ഓഫ് റെക്കോർഡ്സ് ഇൻ ദ ഇൻഡെക്സ് ഫയൽ. ഓക്കെ, number of records in the index file, or the number of entries in the index file. So what will be the number of records in the index file, or number of entries in the index file? Since it is a secondary index is actually what? Secondary index is a dense index. Okay, since it is a dense index, how many records are available in the main file? Okay, which can be equated to the index file also. Okay, the main file is having 10 records or 30,000 records, then this index file is also having 30,000 records. Why? Because it is a dense index. What do you mean by dense index? All the values will be having reference in the index file also. Okay, ഇവിടെയുള്ള എല്ലാ വാല്യൂസിനുള്ള റെഫറൻസ് ഇൻഡെക്സ് ഫയലിൽ ഉണ്ടാവും. Clear? That is the concept. Clear? So the number of entries or number of rows or number of records in the index file is equal to number of records in the main file. Okay, so since it is a dense index, number of records in the index file equal to number of records in the data file. Clear? So it will be equal to 30,000. Okay, number of records in the data file എന്ന് പറഞ്ഞാൽ എത്രയാണ്? It is 30,000. So number of records in the index file is also 30,000. Okay, so 30,000 by what? Blocking factor. Blocking factor we have already computed 68. Okay, so this is ceiling function. Okay, ഇതിൻ്റെ ceiling function which apply ചെയ്യുമ്പോഴത്തേക്കും 441.17. Okay, for applying ceiling function it will be 442 blocks. Okay, next, what is the block access required? Okay, how to compute the block access? Log b to the base 2. B is the number of blocks. Okay, so this is also what? Ceiling function of log b to the base 2. Okay, this is not log 2b, this is log to the base 2. Okay, log to the base 2 plus 1. So since it is a index ആയതുകൊണ്ട് നമ്മൾ number of block access will be log value plus 1. Okay, that is a mandatory thing. Okay, index ആയതുകൊണ്ട് നമ്മളെപ്പോഴും ബ്ലോക്ക് ആക്സസ് will be log b to the base 2 plus 1 plus 1 കൂടെ കൊടുക്കും. Okay, so here the answer is log 442 to the base 2. Okay, എന്ന് പറയുന്നത്, so here the answer will be around 8.7. Okay, ceiling function of 8.7, sorry, 8.7 plus 1. Okay, so 8.7 can be approximated to 9, right? Okay, can be approximated to 9 plus 1 equal to 10 block access. Okay, so 10 block access will be ready. Okay, so this is the a numerical problem based on secondary index. Okay. So today we have covered the clustering index and secondary index. In the next session we will be covering the multi-level indexing. Okay, thank you.